Hello, today we are going to solve one problem from IIT JAM 2020 Mathematical Statistics paper. This is question number 30, the last problem from section A, that means the last MCQ problem. So let's see what is in this question. We are given a random sample of size n from a distribution with PDF f theta x, which is theta multiplied by 1 minus x whole to the power theta minus 1 whenever x is 0 to 1 and 0 otherwise for theta greater than 0. Now to test h naught such that theta is equals to 1 against theta is greater than 1, the uniformly most powerful test of size alpha where alpha is 0 to 1 would reject h naught if which which of this given option is right. We need to find that. Okay, solution. By the question, the random sample is drawn from a distribution with PDF theta multiplied by 1 minus x to the power theta minus 1, where x is in between 0 to 1 and theta is greater than 0. Now under h1, f theta 1 x can be written as f theta 1 x curl can be written as theta 1 to the power n multiplied by multiplication 1 to n 1 minus xi whole to the power theta 1 minus 1, where h1 such that theta is equals to theta 1 which is greater than 1, and if theta naught x curl is 1, where x1 x2 xn is in between 0 to 1. This is under null hypothesis, that means theta is equals to 1. Hence by the NP lemma, by Neyman Pearson lemma, we can write that f theta 1 x curl divided by f theta naught x curl is greater than c, which is equals to theta 1 whole to the power n multiplication 1 to n 1 minus xi whole to the power theta 1 minus 1 greater than c, or we can write theta 1 minus 1 sum over log 1 minus xi is greater than k, or sum over log 1 minus xi is greater than k prime, as theta 1 minus 1 is greater than 0. Okay, now consider the transformation from x to y, where y is equals to minus 2 theta ln 1 minus x. Hence del y del x is equals to 2 theta divided by 1 minus x. This implies the Jacobian, mod Jacobian, which nothing but del x del y is equals to 1 minus x divided by 2 theta. Now 1 minus x is equals to e to the power minus y by 2 theta. Hence f of y is e to the power minus y by 2 theta. F of y can be written as, wait a minute, theta into 1 minus x to the power theta minus 1. Therefore theta 1 minus x means e to the power minus y by 2 theta whole to the power theta minus 1. Okay, into Jacobian, the value of Jacobian is e to the power minus y by 2 theta divided by 2 theta. Hence theta theta cancels out. We get e to the power minus y by 2 theta multiplied by theta divided by 2. Hence we get half e to the power minus y by 2, where y is strictly positive. Okay, now we find minus 2 theta ln 1 minus xi is chi squared 2. Okay, then this implies minus 2 theta sum over ln 1 minus xi is chi squared 2n. Then the MP test can be rewritten as sum over ln 1 minus xi greater than k prime. Hence it rewritten as minus 2 sum over ln 1 minus xi is less than k double prime. Hence under h naught such that theta is equals to 1 and size is alpha, then the probability minus 2n sum over ln 1 minus xi is less than chi square 2n comma 1 minus alpha is equals to alpha. Hence option A is the correct answer. Minus sum over log base e, that means ln 1 minus xi whole square less than, here we have 1 minus x whole square log 1 minus x whole square. That means basically minus 2 sum over ln 1 minus xi. Okay, which we write in right here, or I rewrite this. Okay, probability minus sum over log base e 1 minus xi whole square less than chi squared 2n comma 1 minus alpha is equals to alpha. Okay, so we have solved this problem, and that's all for today. Thank you very much.